Good morning, Wyzant students. My name is Gigi, and I'm here to help you with another chemistry problem today. Reminder, I talk pretty fast. Pause the video as you need as we go along. So today we've been given two very similar questions. An element with a specific valence electron configuration has what group and what period. So since the question's pretty straightforward, I would like us to focus, instead of identifying like the skill process, on what resources we need to use. So let's look a little closer at the most important information we were given of our electron configuration. You'll notice that because they gave us 3s2, 3p2, this follows orbital notation electron configuration, but this is an incomplete one. It's an abbreviated form. They literally are just giving us like the tail end of the full orbital notation, but the tail end is the most important part, so we can still answer this problem very easily. So, given that we're trying to figure out an unknown element and what group and period it is on the periodic table, that means the resource we're going to need to use is our periodic table. There are other ways to answer this question without the periodic table with some interesting mnemonic devices, but I'm not going to follow those because I think it's easiest just to use the amazing resource that you've been given. So this is the Regents Reference Table's periodic table of elements. And first thing I'm going to highlight is where periods and groups are on your periodic table. So they're really neatly labeled here. So periods, so the periodic table acts like a grid, and the periods are the rows. So 1, 2, 3, 4, continuing on, and these rows are going, across side to side. And then the groups act like the columns on this grid, and so they're going to be going up and down, and you can see they're labeled by number moving across the screen. So the next thing we have to pay attention to is the sections of the periodic table, which are organized in what's called orbitals, the s, p, d, and f orbitals. So the f orbital is cut off at the bottom just because I didn't have enough room in the picture, but again, we're not being asked about the f orbital, so we can ignore it. And we're also not being asked about the d orbital, so we could ignore that as well. I also just want to make a quick note that helium belongs in the s orbital, but that would be in 1s2, so we can just ignore helium as well. So now I'm going to combine our boards so that you see we have the most important places highlighted, the s and the p orbital, and our periods and our groups. So pulling up our question, we were given 3s2, 3p2. So the coefficient in front, that large 3, corresponds directly to the period. That's true for s orbitals and p orbitals. It's not true for d orbitals. It's not true for f orbitals. But hey, we're not being asked about those. So the coefficient 3 in front lets us know that we are starting right here in period 3. And then the superscripts, the little numbers that are raised up a bit, those tell us how many electrons are in the orbitals. So to figure out the group, you could just add all of those electrons together and count across, or we can go section by section, which is what I'm going to do. So in 3s2, here's 1 electron, here's 2 electrons. The s orbital has been filled. So then we're going to go on over to our 3p. And again, we've got 1 electron, 2 electrons. So that's an unfilled orbital. And we're stopping right here on silicon. And so then we need to look up what group silicon is. Go straight up, group number 14. There's also a really easy way for us to double check our work. Just Google the actual electron configuration of the element you found. So silicon's electron configuration is this mess of alphabet soup, but you'll notice that last tail end was exactly what we were given in the question prompt. So we're going to do the same thing for the next problem. Please pause the video, try this on your own. It'll give you your best learning experience. So then to solve it again, coefficient out front gives you the period. So we're starting here on period 4. And then the superscripts will tell you how filled, how far across you go. So 4s2 is filled, 1, 2. And then you have 1 electron making you fall on gallium. and gallium is in group 13. And again, you can double check this by looking up gallium's configuration.